Hello again. Unlike the last video where Yocto didn't work, well, we had problems using bitbake to build core image Sato. I just want to create a simple Linux boot up disk, or not even a disk. At the moment we just have a boot up root file system that has a very simple executable. It's not an init, so it doesn't have inittab, doesn't have systemd, it doesn't have anything to do with that sort of stuff. What the kernel needs when it boots up is to run a process. This process has a PID, process ID of 1. If that process terminates, then the system shut down. So if this process keeps looping, keeps running, then the system is kept alive. So normally it's systemd or init that runs inittab, so it runs a whole bunch of system startup scripts and stuff, and then launches your X window. And so when it terminates, then that's when the system shuts down. So knowing that means any executable can be used in place of init. So you have any process that is kept alive can be used. So basically all you need is a kernel and an executable file. So for embedded systems, when you design embedded systems, you normally have a kernel in the boot file system and a init or executable file in the root file system. If it's all in one file system, you probably need grub or lilo, Linux loader, to boot up the kernel. But for our example, we're going to use QEMU with the dash kernel parameter, and I'll show you what's going to happen. It's a previously made example, so I made sure it works, so it saves time. Okay. First of all, you want to see the QEMU instruction. So we did dash kernel and VM Linux. VM Linux is just a kernel, Linux kernel, which I copied out of boot. It's my boot VM Linux. So any kernel that can load up executables or inittab should work. Should work. So I just copied my kernel. And then we'll generate init ramfs, initial RAM file system, and then we'll append the append is the console, is the kernel parameter. So VM Linux takes kernel parameters. It's like in grub or lilo you can specify kernel command parameters. This is what it does. So we set the console to TTY0 and init to run this program in the root directory /init. Init equals can be sbin /init, that's what it normally is, but we just change it to /init for now. Okay, so what sort of program should we create? So basically this is a simple hello world. So it's written in assembly, so it doesn't use libc. It uses the syscall write, so it runs the syscall opcode. This calls a function in the kernel called write to run, and it jumps back to start. Normally this program exits after writing hello world once, but instead we insert a jump start, so it keeps repeating this code that writes hello world. Okay, so we compile that using this NASM and LD to link it up, compile, and then we create the file system. To create a file system, we make a directory called rootfs, cd rootfs, copy the hello program to init, and then use CPIO to add it to an archive. But before we do that, we run hello just to see how it works. So it does work. So it's an executable. It's an executable file. It's an alpha executable that I can run on your modern Linux. Okay, so we create CPIO. Okay, now we've got a file init ramfs, and so QEMU will run it, init ramfs, init rd, and if we run it, look, lo and behold, it boots up a kernel, and it runs hello world. So that's it, really. I think for most people, they would want libc and init ramfs and some other stuff as well. So one of the things they can do is they can build busybox, so it can be a shell. They can run shell commands and everything inside the init ramfs, and they can do the same thing, run QEMU, do the same command. But for embedded systems where you need to just do a simple thing, like Internet of Things, then just a simple executable is just fine. It's just good enough. You don't need a busybox. You don't need a shell on your embedded device. You can even write your own shell. Like you can write your own shell interpreter, command shell interpreter. It's not hard. It's basically like something you give a uni student to do as an assignment. Alright, that's it.